Okay, so we will begin from where we ended our last meeting. Then we move on to the agenda for today. So today, the main agenda will be evaluating or processing video files. So we'll first complete our image processing task, then move on to the video processing. So I'll go ahead and share my screen. Good. So let me go ahead and run all this again. I know we have to mount my J drive again. So I'm hoping you all have. Okay. Go to the drive. Okay. Oh, someone has removed my. Okay. People keep moving my stuff up and down. So this. Oh, man. Sound mode computer vision. Just my images. Look at that. Oh, so let me stop sharing and upload. Uploading my files there. I don't have it anymore. Name. Okay. Okay. So I have to restart this. I don't know. So one of the problem with Google Colab is, anytime you add any new file to your drive, you have to, restart the whole um, item file again before you can get access to that new folder you just added to the file. Okay. So I have this folder as image2. Um, this is image1. Okay. So we did this. Did that. Let's see. Okay, over here. Okay, so this was where we got to our last meeting, where we visualize the two images, looking at it when we are visualizing the blue channel first before the red, and when we are visualizing the red before the blue channel, right? And we said that for humans, we see the red channel first before the blue channel. Okay. Maybe some organisms see the blue first, okay? Yeah, okay. But sometimes when we have images, okay, when you have images sometimes, for example, the bomber image over here, probably there's a lot of black pixels in there, or there's a lot of white pieces, or there's a lot of like a certain part, there's a certain color that dominates in the picture. And we want to find out which color actually dominates in the picture. We can plot each pixel and find the frequency, okay? Now realize that when we print out the image, right? When we print out the image, it gives us an array of numbers. So something like this, look at it. So it gives us this array of numbers. And we said all this represents what? Pixel values, right? So 20204, and we're getting closer to white. So it could be this this values over here, you know, light blue, kind of as you are seeing over there. So they're very difficult to plot these values. So what we do is that we'll convert all these values into an array of numbers, okay? And to convert this one to just an array of numbers, we use the function, this function we have over here, yes, called a ref. And what this does is that it converts it to just one array of numbers. So it takes the whole image and converts it to just an array of numbers. And with this array, we can plot it, right? And find the frequency of each um, pixel in the image. And with that, we can threshold some of it, or we can cut off some of the pixel out. So we can plot it. When we plot it, you see. So realize that um, we said when you are getting closer to zero, like we are getting,
Abo,
yeah,
can you explain the ravel again? Image dot ravel.
yeah. So it's an inbuilt function that will convert the matrix into a single array. So let me say it flattens it, right? It flattens that three-dimensional array into a one-dimensional array.
Makes sense now. Thank
Okay.
you.
So we plot each and every single value and find the frequency, right? So we can see that, hey, there are some white pixels and it has a very great frequency, a lot, right? And we will check in the video what's the picture. You know, there are more that look at the background, it looks like more of white. Look at the black and the white, you know. So it's plus for us to know the frequency of the pixels. And if we want to threshold some, we know how much to remove from. What happened? Oh, okay. For some reason, our web browser just closed. Wow, my web browser is closing on me. Oh, Well, we have a little challenge here. I have my web browser closing. I don't know the cause of it. It's just closes anytime I restart it. But I'll say that we have done almost everything that we are just about talking about the thresholding, which I think will do much of it when we start the video processing. Okay, so we shouldn't lose that much. I don't know why it's Google Chrome is closing up. So we will quickly move on to today's lecture. That's processing images. Okay. So I asked you guys to set up PyCharm. Um, ask you guys to set up PyCharm environment, and I'm expecting that you were able to do that. Okay. So I'll share my screen. And we'll start coding everything from the scratch. Okay. So if you have your Python environment, okay, you should have a certain folder that contain the kind of projects you're about to do today, right? And I'm hoping all of you have been able to set it up, okay? So now we can try testing whether we have all our packages in there. So we'll try and import OpenCV, CB2, okay? Then we'll run. So I right click on the screen, then I go to the run button, see run class, and I click on this. Okay, so it's finished with no error. What it means is that I have the package in there. So now when you try this code and you run it and you get an error, what it means is that you don't have this package in the environment that you are working in at the moment now. So to have this package, you need to go to File, go to Settings, then go to the project you're working in, then choose the Python interpreter. It'll give you an add option. Then you add and install the package from there. Okay. The package will be called OpenCV Python. So we need a computer vision Python for this class. We will need pandas to read our CSV file. So I'll import pandas as PD. Okay. Now, the reason I'm doing this is because pandas has several functions in there. And as such, if I want to call any function in pandas, I have to say pandas dot this, pandas dot that. So to prevent myself from typing pandas each and every single time I want to call a certain function in pandas, I just want to use PD, okay? The same as NumPy, okay? As NP, okay? Same as NumPy as NP. So the NumPy also helps us manipulate numbers. So I'll run this again. From here, I can run it from here, run the class, and it's running, and it has finished. If you look down there, you have seen over here, it has finished with no errors. Okay.
I can't see your screen. No.
Oh, you can't see my screen. Can you see my screen?
I can see now.
I can see your screen.
Okay. So you run with no errors. Okay. So from this point, we want to utilize the part in which we have our video file. Okay. So let's create a path to our video file. So let's say vid path. So you are creating the path to our video file. So you want to put in the path where we can find our video file. Now, if your video file, okay, is in the folder in which you created this Python file, you can just call the video name, okay? That will become, I don't know whether it was 8.mp4. If you have it in there, okay? But if you don't have it in there, then you have to find a path to that particular video file, right? So for me, the path is in my, I think in my downloads. Okay. So I'll go to my downloads and pick it from there. So I'll say right here, I'll go to users, my dollars, my users. Then my users have a folder called Armstrong. So you see the folder comes in here. Then inside Armstrong, I have my downloads in there. So these are the documents in Bash. If I go to downloads, then in the downloads, I have the video here. Okay, so I can put it here. Okay, so I've set into where my video file is. So this is the part of my video, right? So you also do the same thing. Wherever you have your video on your computer, so after you guys download the video, you just have to find the path to the video file and store it in a variable called vid path. Now the path to our CSV file. So CSV path. Okay. So I think it's the same path. Is in the downloads. Same path. This is CSV. Yeah. Okay. So now I have the path to my video and the path to my CSV file. CB2, as I said the last class, is a very powerful package that allows us to manipulate videos and images. It's one of the powerful computer vision libraries. Okay. Now, how then do we read the video file? This is what we do. The CB2 has a function called video capture that enables us to read the video file. So I'll create a variable called cap is equal to CB2 dot. Okay, so you see that when I write these dots, it gives me the various functions I can call out of CB2, right? So then, so it brings it out video capture. Then in this video capture, you have to pass in the path to your video file. Okay, you pass in what? The path to your video file. So over here, I will just say video path. Over here, I'll say video what? Path. Now, what's this function that is like, take the video capture as, hey, you are starting your camera or you are starting to video something, right? So you have it start on, right? Now, each time you do this, it's going to take each and every single frame in the video. Now, note that every video is made up of frames of pictures running at a certain speed, right? That we call it frames per second. So how many frames are showing within a second tells us how fast the video or the video will be, right? So it's a series of pictures that is moving at a certain rate per second, okay? So it's the same thing. We are going to take each and every single frame. That's what OpenCV does. Then we manipulate each and every single frame. So now to read in every single frame, OpenCV has a function called read. Now we have read a video into this variable called cap. So we have to read the frames, okay? We have to read what? The frames. Now this function read returns two outcomes. It returns the frame and it returns another variable called a Boolean. So over here, I'm going to say, let me just use rs, comma, frame is equal to this. So when I do cap.read, it's going to return two things. It's going to return the frame and a Boolean, right? Now, the question was a Boolean. It's either a true or false statement, okay? It's either a true or false statement. So when it reads the frame successfully, res becomes true, okay? When it's unable to read this successfully, it becomes what? False. Now, since we want to read each and every single frame, okay, in the video, we have to create a while loop, meaning that let me create a while loop here. So while true, I'll explain why I'm doing this. Okay, let me do the indentation wall. So we have to make sure you're indenting wall. Okay. So while true, what it means is that if each and every single time it reads the frame successfully, it should continue. So the loop only breaks if RE returns false or there's a false statement, then the loop will break. Are you okay? So when there's a false statement, the loop is going to break. Okay. So over here, we are just reading each and every single frame. Then when we read the frame, we want to show the frame. So we knew that from this function, image show. Then over here, it takes in two input arguments. Okay. The first one is the name of the frame. Okay. So the title we want to give it. So probably I want to give it a certain title, like let's say come. Okay. Then I'll pass in the frame that I've read. Okay. So I read the frame over here successfully, and I'm passing the frame through the show. So this is going to show it each and every single time a frame is read successfully. Okay. And when you are done, you want to tell the computer how long it should wait before reading the next frame or before the next frame should be read, right? So we have OpenCV as a function called the wait key, right? And then in the wait key, you determine the wait time between frames. Okay, you determine the wait time between frames. So for example, if I say 1 millisecond, okay, 1 millisecond means that the video is going to move really, really fast. Okay, mean that just wait 1 millisecond between each and every single frame you read. So read, then moves again. This is just a wait time. Then when you are done, you want to, if I want to stop playing the video, what do you have to do to stop playing the video, right? So you have to bring an off key. So then we have to bring an if statement that if this is equal, if the wait key is equal to this, and someone presses the off key, which is equal to a certain variable that you want to use, any variable. Normally, I like to use skill for quit, but you can use any variable at all that you are comfortable with. Yeah.
What's that before the XFF? Is it at?
Which one?
Is it the end?
And yeah, this is end. It's just shift 7 on my computer. It's shift 7, right? So I'm saying that hey, if
after the end.
Oh, it's 0xff.
0. Oh, okay.
Break. Okay, so I'm saying that, hey, if you are reading the video and I press Q, break it. But before then, for each frame, it should be 1 millisecond between each frame. Okay. Then when you're done, we have to release the video. For over here, we captured it, right? So we have to release it. So cap.release. Okay, cap.release to release the camera. Then if any windows are closed, you want to close all windows, okay? Because it creates like, so destroy all windows, right? So this is a very simple setup, which I think we have all understood how we can successfully read a video file in OpenCV. So I'll go ahead and run this and see. Okay, so you can see it's moving really, really fast. So I press kill and it ends, okay? Now let's assume I change this to 30 milliseconds and run this, and let's compare the speed. You can see this is much slower, right? Good. This is like a normal speed. So kill. So we're reading it frame after frame. So what this is doing is that, hey, it picks the first frame.
Abba,
Yeah.
what is? I can't see anything running.
On your screen. Can you see my screen?
Yeah, I can see your screen.
Did you see the video running?
No, can't
Oh,
see any video.
okay. Can you see my video running?
Yeah, I can see now.
Okay. So first, I checked first, it was 1 millisecond. So when I run this, okay, it moves very fast. Okay, very, very fast. So you can just change the time between how each frame is supposed to read, the time interval between each frame. So if I change to 1,000, it's going to be a bit slower, right? Because it's going to wait 1 second before reading the next frame, right? So you see the video is moving very slow, okay?
I'm still getting an error.
Can you share your screen? Let me see
Okay.
where the error is coming from. You have access to share screen. So if attribute CV has no wait key. Let me see the remote control.
Oh, okay. Thank you.
You're welcome. Let's go share screen. You can stop sharing your screen. Okay,
Okay.
good. Okay, so we have learned how to read images, right? Now, what happens here? I'm passing a video file through it. Now, what if I change this? So if you have different cameras, okay, you can now set your cameras in there. So like how they do video monitoring installs and stuff, right? You can set up your own stuff with your phone and stuff. So if I have my phone connected to this, I just have to pass in the camera ID and it's going to capture that, right? So if I pass in 0, it's going to use my webcam, okay, and record me. So I'm passing in 0. So if I change the video part to 0, I'm going to switch it to my webcam because my webcam has an ID of 0. Okay, then I'll run this. Let's see. So, I mean, it will show me, okay? Good. Okay, so you can, have you tried using the 0? Did it work? If you have a webcam.
Yes, it worked.
Okay, good. So that's how you can also record yourself. We're also using OpenCV to do other stuff, right? So it's whatever you'll be doing to just be recording you and all that. And we can also write images. We can also save videos, right? To learn about all that. So let me just pass my video part in there, okay? Good. Now, let's try and manipulate the video that we have, okay? Now, we have been able to read the frame successfully, okay? Before we can do any changes to images, normally we convert it to grayscale to make it much easier for us to work with, okay? So I create the frame, okay? And I do CV2 dot convert color. I know you guys are familiar with this function because we used it yesterday, okay? So for convert color, what do we do with convert color? We pass in the frame. That's a new frame we are reading. Then we do CV2 dot color all BG to gray. So color all BG to gray. Okay. Then we'll pass and show that gray image and see what you will have. So now our colored image has been turned to gray. Okay. So now we are visualizing gray video now. Good. Now, normally we want to, let me go to around the video. Now, as you see the video running, right? First, we want to be able to identify each and every single video in there, right? And OpenCV can help us identify or help us to get some bounding boxes around each image moving in the video. Okay.
Hello, Armstrong.
Yeah.
Yeah, sorry to cut you short, but then I wanted to ask, before you did the color H something, before changing it to gray, did you reverse the video capture 02?
Okay.
Because it looks like mine is still showing my webcam.
He changed it back to the video part.
Oh, I changed back to the video.
Oh, okay. And what's the code for the gray?
It's just color from BGR to gray.
Okay.
Okay. Okay, so as I said, for the videos, we want to identify the objects in the video, right? By drawing bounding boxes around them. Okay, and to classify them as well. But OpenCV cannot do all this, right? So there's some part of machine learning where we feed the model with some information about vehicles and train the model to be able to classify each and every single vehicle over there that, hey, this is a car, this is a truck, this is a car, this is a truck, right? So now the CSV file that I shared with you, okay, let me go for the CSV file. Downloads. Okay. Okay. So this is a CSV file. Let me explain what's in the CSV file. So in this CSV file, there's a frame ID. Okay. There's a frame ID. There is an ID for each and every single, each and every single object, and there's a score, okay? And that's the probability of the object being identified. Then this is a class, okay? This is a class, the class of the object. So, I mean, I think two is car, yeah. And these are the coordinates of the bounding boxes, the coordinates of the bounding boxes. These are the coordinates of the bounding boxes. And the start and end time. Okay, that's fine. So like what we see over here is a pre-processed information that has been gotten from a model, right? So we pass the video file into the model and it comes out with this CSV, okay, which we will do how to get this information when we do machine learning and deep learning, okay? But for today's class, we want to find a way to draw the bounding boxes on each vehicle, okay, the bounding boxes on each vehicle. Now, for every frame, there's a number of vehicles that can be identified in the frame. So when I pass the frame through the model, the detection model, it identifies each and every single object that is in the frame and classifies it. So if there are 4 vehicles in the frame, let's say the frame is frame 1, it identifies those 4 vehicles and classify them, okay? But when we look at this, realize that the frame IDs have been, arranged in a certain funny way. But frames start from frame 1 to whatever frame that we have, okay? So we can, this has a function called filter, okay? We can go to filter and we're going to do this. We see that it starts from frame 3 to frame 3000, okay? Frame 3 to frame 3000. But for example, let me just take frame 3, okay, and visualize for you to see frame 3. What happens? So in frame 3, it identifies only 3 objects in frame 3. Now look at it. The frame number is 3, but 3 objects have been identified in frame 3. So when it gets the frame, which is a picture, it saw only 3 objects, and those objects were the same. Maybe I think they were cars. I don't know what objects are, or they could be buses. I don't know what the 1 and 3 stands for, the code, okay? But it identified this object. Let's say the 1 is a bus, okay? So now I can go to frame 4, and frame 4 to 3 objects were identified. Go to frame 7, there's so many objects we identify in frame 7. Also 3 objects, okay? Frame 1000, this. A couple of objects were identified, okay? And these are the bounding boxes. So now we want that, hey, when we take frame 7, we want to draw these bounding boxes on the objects that we get, okay? So that's what we want to do now.
Abba,
Yeah.
one quick question. Like, what do you mean by bounding boxes?
Okay, so it's just a square around the object. Okay, so when you identify an object, you identify an object using a certain threshold and a certain box, right? So you draw a box around an object. Hey, I've identified this object from the background. Are you okay?
Okay.
Yeah. So
And
let me show.
how do you detect that this will be the score, like the probability of identifying
So
the?
this is done through machine learning. Okay.
Okay. Okay.
Yeah. So we program that with machine learning, deep learning. So for example, if I have a frame, so this is a frame, okay?
Mm-hmm.
This is a frame, the image frame. Oh, crazy. And I have an object here, an object in the frame. I have an object in the frame. Yeah, it's another object here. It's a big car. Oh, right. Now, what we do is that we draw bounding boxes. If you are first to do that, we have to label them. We told that we feed machines with information, and information we feed the machine with. The information that we feed the machine, we have to give it labeled information. Okay, labeled. So we tell that this is a car. How do we tell it's a car? We first draw a bounding box around this. We draw a box around this object. Okay, and this is what we call the annotation. We draw a box around this object, and we call it car. Okay, and we call it car. Then we'll come here and draw a bounding box. So bounding because it's surrounding it, right? We are just going around it. And it's okay. This is, let's say, a track. Let me just use T for track. Right. So we get several images, right, which has tracks and cars, and do this kind of labeling, okay, and push it to the computer. And I said what it does is that it extracts features from this images you have given it, and okay, and it tries to learn from it. Okay, oh, this feature and this feature looks alike. Okay, so this is a car. Because you have played with several varieties of cars, okay, it learns the different features of how cars look like, even their sizes as compared to tracks. So then if I give it a new image like this, I give the model a new image like this, the model is not going to say this is a car, even based on the size, right?
Okay.
So it's okay, maybe this is a truck. Okay, maybe this is a truck. If you say maybe this is a truck, then probably it will try to find features in this object similar to what it has learned before. But
Okay.
if the features it gets from this image is not similar to what it has learned before, it will have a very low confidence level as a track. So maybe say, oh, maybe this is 0.3.
Okay. So that's how the scores come about.
Yes. So although it identifies as a track, it's not very confident in it. Right? But if it identifies as a track and is very confident, you can get like this, hey, I know this is a track. I'm 99% confident it's a track. Okay. So really the score values vary based on how confident it is about the object it has identified.
Thank you.
Right. I hope it's well explained, right?
Yeah. Very.
Okay, good. So this image we have over there is a process image. Okay, it's a process image that we have used a certain vehicle detection model to detect the various objects in the video. It has given us the output as we see in there. Okay. So let me stop sharing and share the screen. Close this right. Okay, good. So we realize that the confidence is different, right? You realize some is like 0.8, some is like 0.9. But it is very sure that, hey, this is the object of identify, right? So these are all very good confidence that is identifying this object correctly. Okay. So we are not coming to do this where we are coming to build a model. Over here, I just want to plot this on and visualize it. Okay. Then subsequently, we'll learn how to identify the object itself and draw bounding boxes around the objects. Then we can also learn to train a model to identify those objects. Okay, So I'll stop sharing. I've explained the CSV file to you. So let me go back to my PyCharm. Okay, so I'll read the CSV file, okay? And to read the CSV file, I use a library called pandas, okay? So pandas allow it to manipulate data frames, tables in the form of table. It has a lot of functions. So it's one of the very good libraries in Python that we can always use. So I create a variable called data frame. Then I
hello?
read, yeah.
Wow, that's
We see
sharing.
still the Excel. We don't see the pie chart, PyCharm.
Oh, share screen. Can I say my PyCharm?
Yes.
Okay. So pd.read CSV. Okay. So our file was a CSV file. So we do pd.read CSV. Then we pass in the path to the CSV. Okay. So this is our CSV path. Okay. We pass it here. Okay. So now let's try and print out the DF. Okay. Let's print out DF. So print is a print function, print DF. And before I do that, let me comment this. And to comment this, I highlight the whole thing. I'll comment this. I highlight the whole thing, and I use control and forward slash. Okay, control forward slash. You comment everything that I've highlighted. So I'll run this. Now we can look at my console, and it has read the CSV file, right? So there's a frame, the ID, the start time, and and the rest. Okay, but I just break stuff that is reading a lot of stuff in there. Okay, so I've been able to read my CSV file successfully into a variable called df, which is our data frame. So I'll comment this out, and I'll go back and uncomment this. That's highlighting the whole thing again, and control forward slash. Okay, I'll comment all that again. Please, at this point, any questions before I move on? Any questions?
No, please.
Okay, good. Okay, so we are done with this gray image. So you might not need this gray image again. We just want to show that we can convert to gray image. I mean, take it out and later count this. So I've read my frame successfully. Okay. Now you realize that in our CSV file, we have a place called frame, right? And that's a frame number. So what I want to do is that I want to get the number, the current frame that I have read. So this reads a certain frame, but we don't know the frame it has read. Okay, so I can get the frame number. So I want to say, okay, I'll create a variable called current frame that I'm reading right now. So a variable called current frame. So what frame am I reading right now? And to get that, I want to use this to know, okay, what frame has the cap.read read? So I go to cap.get, okay? And in the get function, part cv2 dots has this properties, capitals, cv2 dots cap. Yes, this one.
Well,
yeah.
Let me ask one trivial question. After you finish commenting everything, if you want to uncomment it, like what's the shortcut?
I said you highlight the whole thing you commented, and the same thing you did. Control forward slash, yeah, you should comment it. Okay, so now this function cap.get the properties of the frame, so it gives you the current frame. Okay, so let me see something. Let me comment this. going to comment this and for you to see what the function is doing. Okay. And let me print out the current frame for you to see what it's doing. Print current frame. So I print this out. Now you can see it's what is printing down there. So it's printing the frame that is reading. Okay, good. So I stop this. Let me uncomment this. Then yeah, take this thing out. And it's showing this. Okay. So now when we get a current frame, we're going to say that okay, we have a pandas file. Okay, so we have read the file already. Okay, so we'll create a new data frame, which is let's say data frame 1. Give it a new data frame. And this data frame, we are going to filter out all rows that has this current ID. Okay, so what do? We look at the rows, which is frame. So frame is our reference point, right? So look at frame and also, okay, frame is equal to, that's a logical statement, is equal to the current frame. Okay, so assuming that it's like the way we filtered in Excel. Okay, so when I come to Excel, the same thing I did in Excel, what did I do? I do this. So if I want to filter out, I say, okay, this. And what it does for me, it gives me only the rows that correspond to this particular frame number. Okay, because I was filtering by the frame. So this is the frame. Now we know that the current frame gives the current frame number. So the same thing, we are putting the frame number here that, okay, if the frame number is equal to this, it's like the way we are sorting that in Excel, where we choose the number. Please filter it out for me. Okay, filter it out for me and put inside a new data frame called df1. Okay, data frame called df1. Now let me print out df1. Let me comment this so that you understand every step we are doing. Let me df1 print df1 and run this. Okay, so you realize that for each of them that is printing, let me just stop it. Let me show you something. So for each frame that it reads, okay, so it starts. So when the frame is 12, the current frame is 12, it only picks up the rows that, so right, this is 17, all the rows that have 17 picks it up, right? So that's what I'm doing in the next line, picking up. So when 26 picks it up, okay? So over here, that's what it's doing. So it picks the current frame, then take the rows in the CSV file that correspond to the current frame. Do you all get it?
Again,
Do you all get it?
please can you go over it again?
Okay, so like what we did in the Excel file, right? The Excel file, we gave over here, we can just choose the number from here, right? Because we know the frame numbers from here. So we can just choose the number from here and say, okay, maybe 16. Then we go and filter it out and it gives us all the rows that correspond to having a frame number of 6. Okay, then if we want that of, let's say 3, we do the same thing. We come here, we run this, it gives us only rows that correspond to 3. And that's the same thing we want to do. Because
Okay.
as I explained that for every frame, it identifies certain objects in the frame. So then if I get frame 3 to this is the frame 3, I want to draw this bounding boxes, this coordinates bounding boxes on the images in frame 3 and show that.
Okay.
Okay. Otherwise, I'm sorting out by the current frame. So for each current frame, I know all the images in the current frame. I now have the information about the bounding boxes. Then I can draw those bounding boxes on those images with the coordinates I have. Then we move on from there. Okay. So I can comment this out now. Let me uncomment this. Okay, good. So now that we have been able to get the current frame, oh, I'm not commenting this. Yeah, now I've gotten the current frame, okay? But we realize that when we check the Excel file, okay, look at the frame, you realize that it doesn't start from 1. So frame 1 is missing. Frame 2 is missing. It starts from 3, which means that it will throw an error if you don't give it any condition, right? So maybe it reads a current frame, maybe it reads a current frame, which is the first frame, which is, let's say, 0, right? But there is no ID in our Excel file that is 0. So it comes here and puts 0 over here and say that, oh, filter out a column that has 0 in there. So that this data frame, because there's no column which has 0, this data frame will return an empty data frame. Are you okay? So realize that over here, it returned an empty data frame. So empty data frame, because it read the first one, which maybe it was 0, it returned an empty data frame. Look here, I'm highlighting it, right? The same thing it did for this, okay? So that's what is happening. So we're going to say that, okay, if the F1, or let's say the length, if the length of the F1, okay, is greater than 0, then continue. Now, what it means is that if I find the length of this ones, it's going to be 0 because they don't have any elements in there. Okay, so it's going to be 0. This ones, the 0, 1, 2, 3, it's going to be 0, except that. So I'm putting a condition over there that, hey, if the length is 0, if the length is greater than 0, then continue with this process, or else don't do anything. Are you okay? So I want to do something only if the length is greater than 0. Now, if the length is greater than 0, I'm interested in certain values inside that table, which is the x1, y1, x2, y2. I'm interested in those values, okay? So I'll try and get those values out. So over here, I'll say that x1, I create a variable called x1. And in the x1, I'll put all the x1 values in that data frame after sorting it out inside. Okay, so I'll say list data frame into brackets. I'm interested in the variable called x1. So x1 dot values. Now, let me explain what I'm doing over here. Now, if I do the F1, okay, that's another thing. If I do the F1 and I pass in the variable in that df1 and dot values, this will give me an array of numbers, okay? But we want it as a list. So I will use a function called list, which is Python function, to convert the array into a list. So I will convert it to a list. What it means that the lists, let me try and print this thing out for you to see what I mean. So print bracket x1. That's what it's doing here. So you can see it's create, you see the list. So this is a list of all x1s. So I'll stop it. So now for any frame that it picks, so let's say it picks a particular frame, it has been able to sort out all the rows that correspond to that frame ID. And it's giving me the list of all the x1s. So for example, let me take this as an example. I've been able to sort out the frame by, I've gotten all the rows that correspond to a frame number of 3. And I'm taking all these 3 values. So I'm taking 1, 2, 5, 7, 1, 8, 108. So if I scroll up to my third frame, So look at these values. Look at these X1 values. Okay, look at these X1 values that correspond to the third frame. 1, 2. Let me minimize this a bit. Oh. Okay, so this should work out. So realize that these numbers you see over here are the same numbers we see over here. Are you okay? So I just converted into a list. Good. So I can move on from here. So I'll do the same for all the other values that I need. Okay. So I can copy this, and come down and paste it. And I'll just change it now and paste it. So this should be X2. This should be Y1, and this should be Y2. And I'll change this one to S2, Y1, Y2. Okay, so I've gotten a list of these numbers. Now, because this is a list, I want to plot this on the image, right? So there is a CV2 function called the rectangle. So I do CV2 dot rectangle. You can see it takes the image. Okay, so I'll pass in the frame. That's the image. That's the frame. Then it takes the first point. That's the X1, Y1. Then it takes the second point. That's X2, Y2. Then it takes a parameter that is called the color that you want to, what color do you want the box to be, the rectangle to be, then the thickness of the box, and the type of line you want to use. Okay, so these are the various inputs that you put into the dot rectangle function, okay, to draw a rectangle on your image. Okay, are we on the same level?
Yeah, for me.
Okay, so I'm going to do that. So I'll say that, okay, now I'm going to get the list of each of them, okay? But there's a list, so I have to look through. So if I'm looking through, so I should look through. So for, let me say coordinates, or let me just use I. For I in range 0 to length of the data frame that we are considering as df1, right? So realize that the length of this, right? If I find the length of x1, right, the length of x1 should be the same as the length of the data frame, because if x1 has 3 entries, mean that there are only 3 rows in the data frame, so we're going to have the length to be 3. Are you okay? So I'm saying that, hey, for I in range of this, what this is going to do is that, let me print I. Okay, let me print I. Now, printing I means that it takes the first one, which is 3. Okay, so you're going to do from 0, 1, 2. Okay, it doesn't print the third one. It doesn't print the last number. So if the length is 3, it's going to be, let's say if here is 3, okay, it will only show 0, 1, and 2. Okay, let me just do this. Comments. Let me just comment this and just show you what so let's say for I in range 0 to, let's say, 5, and I want to print I. Okay, it will just print 1, 0 to 4. Okay, So you see it has printed 0. So for I, it prints 0, 1, 2, 3, 4. It doesn't print the last element. Okay. So that's why there isn't that logic over here. Let me comment this. Okay. So for each of them, we want to create a new variable called image. Image. Okay. Then we will pass the rectangle in there. So dot rectangle, which we have seen, right? And we'll pass in the frame. The frame we are reading is frame. That's the image that we are reading from here. We read the image from here, okay? So that's the same image we are using throughout. So we pass in the image, then we'll pass in the first point, right? So the first point will be an index of x1, okay? So let's say x1, and I'll index the first one, I. So for every I, comma, y1, I'm indexing the first one, okay? Now, this takes in an integer, so I have to put the int over here to convert what number that comes over there as an integer. Okay. As an integer. Okay. So this is my first point. Then my second point will be the same thing, but this time around is going to be x2. So I'm going to have s2 here. We'll have y2 here. Then to the color. Now if I should give it, let's say 255 0 0, this should be a blue color. Okay. So we'll learn how we are doing. So realize that we said it's blue, green, red. Okay. So if I do this 255, it's going to give me the correct blue. Then over here, because there's no green and red channel, it's going to be just blue. Okay. Then the fonts we want to use, or the thickness of the box, right? So thickness, we can give it a 1. Passing some 1. Okay, maybe 1 should be enough. 1 should be enough. We pass in 1. Then when we do this, let me comment this now. Comment this now. Let me push this out. Okay. So when we get an image, we want to show the image. So I have to push this here. Push it about this, because when the image comes, I write it on a new variable called image. So I have to pass in image here. I'll pass an image here. So I'm passing the image here in a wait key that yeah, guess everything remains there. So with this, I can run this. And let's see what it does. So you can see it's drawing the boxes on the vehicle, right? So these are the identified boxes, or the bounding boxes, right? Okay, so I can quickly, let me increase the thickness a bit and change this to something like 30 seconds. Then I'll run this again. Okay, so we can see it's clear now. Yeah. Okay, but there are different classes of the vehicle, right? So we want to add the classes, we want to show the classes of this by using different colors. So we want to say, okay, if if the class of the item is maybe this, show maybe this value, or else show a different color. Okay, and it will just be an if statement that we will add to our statement. Show the color differences. Okay, so we have 5 minutes more to end the class. Oh, stop sharing my screen. Okay, that's great. Okay, so now if I want to get the classes, I'll create a variable called this, and with this, let me just copy this here, copy this, paste it here, and here the variable is called CRS, if I'm right. Let's look at our Excel file. It's called CLS. Okay, that's the name of the class. Okay, so we have this. Then we have that in here. Okay, so this is what we're going to do. Now, because we are looking at the classes, right, we'll put another condition here that, hey, when you read the class first, and when you put a certain caveat on the class, that if the class that you read, that particular class index, you read a particular class index for the particular I, okay, and it's equal to 1, do this. Let me push this here. I'm just indexing it well. Do the same thing, but show this blue color. Okay, show this blue color. But else let me just copy this and paste it here. Okay, so I'm saying that, hey, for the particular one that you read, check the class as well. If the class is equal to 1, make sure you show a blue color. If the class is not equal to 1, so that means that this one's not satisfied. If the class is not equal to 1, I want to show a different color. So that I want now to differentiate the variables by different colors. So let me give it this, right? Okay, show this. Yeah, and let's see what we have now. So for the various ones that are the same, so let's say it is identifying castle, identify all this as the same type, so you're showing blue. So then if there's a different class of a vehicle that comes, which is not a car, you show a different color. Okay, so let's see. So realize that this is red because we gave it red. Okay, yeah. So for tracks or stuff that are not cars, it's going to show red. Yeah. And that's one of the ways to show the different classes. Or you can write the class on top of the image by using the CV2 function called put, right? Put test. So let me create this. Okay. So instead of maybe using different colors to show the different classes, we can decide to use the put test, and maybe comment the whole of this. Let me copy this. Okay. Paste this here. And let me comment this. Let me comment this. And let me put a text on the frame. So I can decide to pick a frame and put a text on the frame instead of showing it as a different color. So what do? I will say, okay, image is equal to CV2 dot put test, put test. So it takes the image, it takes the set, it takes the font size, the scale. Okay. So right here, we pass in our image, which is a frame. So in that here, we have to pass in the image that we get from here. So we pass in the frame through this one. Then when we pass in the frame, we want to pass in the class. So we convert the class to string because it is a number and we have to write the text in string. So string class, read the first entry because it's the same class for the object. Then from here, we put in the position of the object. So probably I'll say it should be just slightly above the bounding box that we draw. So I'm giving it a certain coordinates, x, comma, then maybe the y. That's the, so this coordinate you see over here, the bounding box coordinate, this one is the top left coordinates, okay? The top, these are the top left coordinates. So I want to put certain, I want to decrease this by 15. Okay. This will be the top left coordinates of this here. Then we can pass in the font type. That's font fonts. Then we can use any of these fonts. So maybe I like this font. Then maybe color. Let's pass the color. Let me say 0, 255, 0. The color and the thickness. Let me say image. There's an arrow somewhere. 0 means CV2 around this. There's some error. I want to see where the error is coming from. Okay, syntax error. Wait, not rectangle. I don't know where the syntax error is coming from. It's not showing anything. Line 25 here. And, supposed to be the same thing too, though. Let me copy this. And paste it here. Paste this here. And change this to image to img. And Very sure it's from the puts. It's from here. The inputs are not complete. Yeah, the input in the text are not complete. So let me see why the text is not complete. Oh, left some argument out. So I have to indicate the color, then the font size, which I did not indicate. That's the reason why the font size, then the color. Yeah. Okay, so I didn't indicate. It's supposed to give us this font type. Fonts. Setting color. This. Okay, here too can be a problem. Yeah. And it's just a bracket. So you see that it has written the class on top of, see the one on top of the bounding boxes now. So that's one of the things you can do to put a class. Either you write it as a text, or you can use colors to differentiate this. So you can see still blue, but it has a different number on it. Yeah.
Can it be written like in names, like instead of one, like a car?
What do you say?
Instead of writing one, probably to indicate car.
Yeah, you can use colors to differentiate the different. Yeah. Good. I mean, this thing that do happen in programming, just something small. So it was just a simple bracket that we are missing out in the equation and was messing up. Yeah. So that's it. We have been able to draw the bounding boxes on it. And the next time we will have to draw our own bounding boxes. Instead of using what we have been provided, we create our own bounding boxes from the video itself. Okay. So how do we extract stationary objects from moving vehicles, like moving objects in a video? That's what we'll do the next. Yeah. So if you have any question, you can ask.
Thank you. It's not a question, but I'm just making an appeal.